The overall aim of the project was to facilitate species distribution modelling in a way that was in alignment with ecosystem-based monitoring principles. So an ecosystem-based approach is an approach which looks at the ecosystem as a whole, rather than, for example, single species or single environmental services in isolation. Monitoring on a scale that broad is financially and practically a very challenging thing to do. So keeping that in mind, we wanted to find a way to use fisheries survey data and multi-beam data together. Unfortunately for us, these require different survey conditions. So a multi-beam survey requires a really calm sea, and the boat will go along and back again at a very steady pace in order to collect good quality multi-beam data. Whereas a fishery survey tends to go out in a variety of weathers. It will operate on a much larger scale, and it will go from point to point quite rapidly with travelling speed, and it will stop when it gets to the point that it needs to survey. This creates quite an incompatibility on a spatial scale from the way the two data sets are collected. In order to use these two data sets together, we had to come up with a new approach. The fisheries surveys use a software called OLEX, which is commonly found on fisheries vessels, and it looks at multi-beam data in real time. This allows the person on the boat to look at the seafloor as they're going along and to make a decision about where to put gear down kind of safely and appropriately. This data is stored, but it isn't analysed. So it's collected at quite high speeds, and it zigzags across an area, and is basically everything you don't want in a multi-beam data set. So no one wants to use this data apart from us, basically. We realised early on that there was no way this could be analysed in a traditional method, so we teamed up with the computer science department at the University of East Anglia to develop a new way to process this data. We settled on a convolutional neural network, a CNN. This is a type of deep neural network which is used to classify large image repositories. So the CNN needed an image, but it also needed a classification system specifically for those images. OLEX records latitude, longitude, and also a value for the backscatter and a value from the bathymetry. We were able to export this data and use it as point data to create an image of the seafloor, where we could see the form of the seafloor based on the depth and the substrate based on the hardness. We then created a classification system using those two values, which allowed us to have a classification bespoke for our image catalogue. We were then able to use this to train the CNN. What were the main implications of the study? So the importance really was in the results of the study. We knew that a CNN could be used to classify a large image repository, but the importance is whether it's relevant to species that were captured in the survey at the same time as the multi-beam data was taken. So creating a habitat classification which is based on the values we had available to us rather than the values which we think of as important to the species in the survey was quite a big risk for us to take. So we created a habitat variable from our outputs, and we attached that to the survey data. And then we wanted to test the statistical significance of that habitat variable to the species from the survey. We compared the variation of species abundance with the habitat variable to a randomised data set for 100 of the species that were found in the survey. And we found a significant result for over 50% of those species. The main point of the study overall was to look at supporting species distribution modelling with an ecosystem-based approach, whilst keeping in mind kind of costs and practicalities of large-scale surveys. Now that we have a habitat variable which is important to so many of the species found in this area, so for me in the future I'm keen to look at how this variable can be used in species distribution modelling. We can keep processing the data over time and developing a larger data set for the area. That will help us to look at possible modelling objectives in the future.